Okay, I think we're rolling. I hope we are. Okay. Folks, who can perhaps tell me the specific coordinate that represents the vertex? Anyone know what specific coordinate the vertex is on here? 1, -4. So we start at 0, 0. 1, -4. Absolutely. That is what we call the vertex. Here's what I got. The vertex is the parabola's, basically the axis of symmetry. It's there. It's there. And it's the coordinates of the highest or the lowest point, x, y. That is like the point of where that axis of symmetry goes right through. Maybe I'll even say that right here, vertex. Okay, we got a new word, a brand new word, and the word is, where is the word? No, zeros. Zeros. Probably wondering what zeros are. Zeros are the x-intercepts. This is a 0, and this is a 0. So points that cross the x-axis where, of course, y would equal 0, because they are in fact x-intercepts, so y would equal 0. Maybe I'm going to go to the graph here and write zeros. I'm going to put an arrow here. Or maybe let's put 0 and then get a couple of them. Zero. Oh, this is a good one. The axis of symmetry. Okay, the axis of symmetry. It's a line that separates the parabola into two identical parts. And I wrote in brackets there the x value of the vertex, which is actually pretty cool. So this vertex, you said it was coordinate 1, -4. And just by looking at the quadratic, you know, like, and I have full confidence that you are able to split this thing in half. So we know that the line of symmetry should be about here. And I do like a dashed line like that. Can anyone tell me the equation of that vertical line, that axis of symmetry? What's the equation of it? X equals +1. Yeah. And it is no coincidence at all that the x value of our vertex is also +1. The reason for that is because this vertex is the point where that parabola changes direction. It's literally on the axis of symmetry. Because it is always on the axis of symmetry, it'll share that x value. It'll always share it. Now that's kind of planting a seed for the future, because that is great stuff. Another new word, optimal value. So basically, the optimal value is the maximum value or the minimum value. We just say optimal because that's a great umbrella term for maximum or minimum. We'll just say optimal. So when we want to find the optimal value, we kind of got to make a decision on whether this thing is going to create a maximum or whether it's going to create a minimum. Because the parabola is smiling, it's happy, is this a maximum point? top of a mountain, or minimum point? Minimum. Minimum. So we'll say this parabola creates a minimum value of, and this is it. And we just look at the we just look at the y-axis, -4. So that right there is our minimum value. And we know because that's as low as this thing goes. The lowest point is -4. So far, so good? Questions about anything so far? And there's one more thing in here that I kind of just swooped in there, and it's the y-intercept. And I know you know this stuff. You're really good at it. The y-intercept is the point that crosses the y-axis. Oh, I don't know if I want red here. Maybe orange. Right here. Of course, the y-intercept is -3. Wow, good stuff. That's a ton of new terminology. Tons. But it's not bad. Not bad. Questions about anything? Okay. In this parabola, yeah, ax squared plus bx plus c, we actually don't have the equation, but would you say that the a value right here is positive or negative, and why? Do you think it's positive or do you think it's negative, and what? And why do you think that? So you say positive because it's going up. You mean it's opening up. It's smiling. It's positive. We're like, yeah. And what do you think the C value actually is? The C value. Do you remember the C value? Yeah, the C value is really the y-intercept. That's the y-intercept. So yeah, we'll say C for sure is -3. A for sure is positive. Okay. Oh, that's good. That was really good. Let's examine this parabola here. Examine the following parabola. Okay. What do we know about this sucker? All right. What's the y-intercept here? Who's got it? Y-intercept. What do you think? Yeah, -3. Now, do you put y equals -3 or you just put -3? I'm not entirely sure. I think maybe y equals -3, the y-intercept. What are the zeros of the relation? Now, hold on here. What is zeros? What are zeros? Does anyone remember, Crystal? Yeah, zeros are those x-intercepts. So we have one here and one there. So we have one at +1, and we have one at, what's going on here? +3. We have 2 zeros. We're lucky. Sometimes you can have no zeros. Sometimes you can have 1 0. And we'll get into that. What are the coordinates of the vertex? Coordinates of the vertex. Someone new. Who's got it? Gabriel. 2, 1. Absolutely. That's the vertex. So you could put coordinate 2, 1, but because it's the vertex, and because I'm telling you, this is a special coordinate, I put a V right beside it. And that will let me know that that coordinate is not any coordinate. That coordinate is the vertex. What is the equation of the axis of symmetry? X equals 2. And you know that because this axis of symmetry, boom, goes right through the vertex, of course. And that right there is a nice line. Does it go on forever? Sure. And we got x equals 2. Oh, wrong way. X equals 2. That's the equation. And that's important to know. Equation of the axis of symmetry. So once that equal sign. What is the optimal value? This was a new one. Brand new. Yeah. It's +1. And you know that because you're like, well, where are we on the y-axis here? It's +1. And also, oh yeah, well, I don't want to go too far ahead here. Now, is this a maximum or a minimum? Maximum. You can just put max. In fact, if having to remember maximum and minimum are causing you some troubles, I remembered it like this when I was in grade 10. I would say, like, max is set, yeah, and minimum is like Minnie Mouse, yeah? Like, obviously super, super happy, for sure. Like, that's a maximum, and this would be a minimum. Cool. All right. Now, we're given a nasty one. We're given a real nasty one here. Says you create a table of values for this guy here. Okay, here we go. We got y equals x squared minus 3x minus 10. And I wrote it here for you in the table. And I also left a ton of room in that y part. And I'll tell you why I left a ton of room. In this quadratic, we're going to have to replace the x value with the x values that we have chosen over here. Like I said, usually -3 to +3. Here we're doing -2 to +2. I think if I were to ever ask you, I would tell you, hey, do -3 to +3. So what we're going to do is, do you ever have a calculator? Now the reason why I'm asking is because if you ever have to do this, the best way to do this is in a calculator. In one shot. If you type this in very carefully, so I'm going to go, okay, bracket, open bracket. Do you need one? No? All right. Open bracket, -2, close bracket, squared. So I'm doing this one here. So I'm thinking, okay, it's going to be -2, close bracket, squared, -3 times -2, minus 10, and we'll see what that equals. -3 bracket, -2, close bracket, minus 10 equals, and when I hit equals, I get 0. Now don't clear your calculator or anything. What you can do is just go back into where you type this in and go ahead and backspace the DEL button, or maybe it just says, like yours says, DEL. You can go in there and backspace these things and then fill in -1. And then go in there and backspace that and fill in 0. Instead of typing this in 4 or 5 different times, you can just go in and backspace your x values. It's so good. It saves a ton of time. Honestly, the best life hack. So for this next one here, you're going to go over here in your calculator and backspace the -2, or you can just backspace the 2 and put a 1. -3 times -1, minus 10. Anyone got an answer here? Oh, I got it. Anyone got one? -6? Yeah? Just want to triple check here. This calculator is not doing it for me. Aha, I got -6. Boom. And then you could just go back into there and we're going to type in 0. But if you're clever, you know that when we type in 0, what's going to be the output here? What do you think, Maggie? Yeah, -10. And we know that because, well, we put in a 0 there, a 0 there. All we're left with, anything times 0 is 0. We're just left with a -10 anyway. Now let's see what happens when we get rid of that negative. We type in +1. +1, I backspace it. There you go. I got -12. Anyone else get -12? You confirm -12? Okay. If we're wrong, we're wrong. -12. And I'm going to go in there one more time. Change this to a 2. Backspace that 2. What'd you guys get? No, it doesn't. I think when I typed in 1, something must have messed up. Did you get -12 again?
Yeah.
Yeah. It doesn't seem right, does it? Let's have a look at what this thing looks like. 2 squared is 4, minus 6. 4 minus 6 minus 10 is certainly -12. Interesting. Well, let's go ahead and graph this. we got negative 2, comma, 0. That is coordinate number 1, right? Negative 2, comma, 0. The next coordinate would be negative 1, negative 6. So we go negative 1, negative 6. Yeah? Next one, we said 0, negative 10. Not that. 0, negative 10. Okay, okay. The next one we got here is 1, negative 12, which we said felt a little weird. And then we have here 2, negative 12. Huh. Just for the sake of funsies, let's see what would happen if we had a 3 in here. What do you think we would get? What do you think? Whoa. Did you type it into your calculator? No. You just looked at the graph? How did you know? Oh, she's got it. Maggie recognized that these two coordinates are the symmetrical coordinates. That axis of symmetry, she said, is at 1.5. It's gonna cut this thing right here. Just like that. So the next point over should match up with this guy right here. But that's it. That's so interesting. So I'm gonna type this in my calculator just to double check. 3 squared. Okay, minus 3 times 3 minus 10. Boom. And we get negative 10. Absolutely. So, negative 10. What do you think the next one over, when we go over one, what's the next one going to be? Probably here. Because these things are symmetrical. It's got to line up. And also, if we go over one more, it's got to be here. It has to be. Has to be. So, when we slowly but surely graph our smooth curve, we got to remember the vertex is somewhere down here. We don't know where, but it's somewhere down there. Here we go. Folks, the equation of the axis of symmetry. Maggie, you said that it was x equals 1.5. Yeah? And we know that it's got to be right here, between 1 and 2. X equals 1.5. Now, I'm going to hold off on the vertex just for a moment. And how about the y-intercept? You want to see the y-intercept? Where's that at? Negative 10. Maybe we should put y equals negative 10. Sure. How about the zeros or 0? Which one is it? What are the zeros? Yeah, we'll say x equals negative 2 and then x equals 5. Those are the two zeros. We got them here and here. And is this a maximum or a minimum? Minimum, absolutely. Now, this vertex, this is actually a really funny one. We know that, now this is something we're going to get into a little bit later, but we know that the vertex, yeah, it's going to have an x value, it's down here. It's going to have an x value of 1.5. Do you agree? For sure. It's going to be, the vertex is going to be 1.5 comma something. And we don't actually know what that something is yet. If we grab this quadratic, this one here, y equals x squared minus 3x minus 10, and we substitute the x value of 1.5, we will get the y value of when x equals 1.5, which will be the other half of our vertex. So we're going to say y equals 1.5 squared minus 3 times 1.5 minus 10. 1.5 squared minus 3 times 1.5 minus 10, and it's negative 12.25. That's what it is, which is a nasty one. Nasty. So our vertex here would be, well, we know it's 1.5. Whoops, 1.5, negative 12.25. Now that right there, folks, is a giant, enormous stretch. Maybe too soon for that right there. Maybe what else we could do in this sort of situation is graph this thing on Desmos and then have a look at Desmos. Desmos is really good for showing you all these different characteristics about a parabola. So really, that's how you do it. And again, I'm planting a little seed for later. Maybe not later in this unit, but it's coming, and it's so good. Okay. Maximum and minimum values. For quadratic relations, the y-coordinate of the vertex represents the optimal value. And that, again, optimal just means the max or the min value, whatever that might be. Now, it obviously depends on whether the parabola is opening up or down. And this is going to sound very repeated because we just talked about this in the last lesson. Now, the vertex, if the parabola opens up, the vertex represents the maximum point. Hold on here. If the parabola opens up, not at all. If the parabola opens up, the vertex represents the minimum point. And the y-coordinate of the vertex represents the minimum value of the function. It's trying to trick me in this. So this right here, it's smiling, yes. This point right here, that's the vertex, and the minimum value of the vertex is negative 4. So we go over here and say min value is negative 4. Min meaning minimum. Now if this parabola opens downward, like this guy over here, there's the vertex, we go right across, and we see that, well, this is the max value, because max is sad, and this maximum value is positive 4. Okay, well, yeah, you're right. We'll get you one. Okay. Questions? Zeros of a function. This is a weird one. This is going to sound really weird. The x-intercepts of the graph are what we call the zeros of the function. The zeros are the x values when y equals 0. We know this. And the x-intercepts of the function are the roots of the equation. So I'll give you a moment to just write that down. It sounds really, really strange, partly because it is. Okay, everyone have that? Okay. Now, here's the thing. On a graph, okay, we have a parabola. Lovely. These here are what we call the zeros of the function, right? On a graph, those x-intercepts are called zeros. Yeah? Now, at some point, when we solve for those zeros in the equation, I will personally still call them zeros, but some math people out there might say, whoa, those are actually the roots of the equation. In which we say, yes, you're right, they are the roots. But it's almost like slope. Remember a slope? We called it rate. We called it rate of change in y, change. It had like a million different rise over run. It had a million different names. And same thing with these zeros or roots. They're literally referring to the exact same thing, except they're being very technical about it. They're saying, if this is on a graph, we call them zeros. If it's in an equation, we call them roots. Which, for me personally, I don't care so much about. I care a little bit about it, but I don't care so much about it. That's not really what I'm after here. But just so you know, like there might be some math people out there that will lose it over that, and I'm not one of them. I promise. Now, there's three different cases, very similar to how, remember in linear systems, there could be one solution, many solutions, this and that. Same idea, sort of, with the zeros here. There could be a situation where you have two zeros when the parabola crosses the x-axis two times. Yeah, two zeros. You could also, this is a very, very, very special case. There could be a scenario where you just have one zero. If you ever have 1, 0, that zero must be the vertex. It must be, no matter what. These things are symmetrical. Remember we got negative 12 before? These things are seriously symmetrical. And right here, yeah, if we have only one x-intercept or only 1, 0, it must be the vertex. Very, very special case, okay? Lastly, there could be literally no zeros. That's the x-axis. See how it doesn't cross it, not even one time? Those are the nasty ones. But we got a plan for them. We have a really, really good plan for them. Okay? Questions about that? I feel like this is just a learning experience for all of us. We're learning a ton of new stuff, and we're like, okay. Alrighty, we have two graphs. We have the red graph, which is the first column here, yeah? And we also have the blue graph here. And this is good stuff. This is something that I would put right on your in-class assignment for sure. So let's have a look at just the red graph here. Can someone please tell me the coordinates of the vertex? What? And be careful, this graph is counting by weird stuff over here. Coordinates of the vertex. Where is it? About there. Anyone got it? What do you got? 6, negative 4. Yes, I'm going to put a V beside this. 6, comma, negative 4, just like that. Now the equation of the axis of symmetry. Now some of you might already be noticing some of these patterns. Some of us might not even be looking at the graph at this point. Huh? I mean, hey, if you want to look at the graph, absolutely. We know exactly where that is. What's the equation of this axis of symmetry, folks? That's right. This is x equals 6. And some of us might have said, well, in the vertex, right? So I have a V beside this one here. In the vertex, the axis of symmetry is always going to be the x value, no matter what. It'll always be the x value. It has to be. The vertex is literally on the axis of symmetry. Okay, step pattern. Here we go. I'm going to pull out a different color here. Looks like we go, it can get a little bit nasty. That's okay. We're counting by 2s here. Yeah? So over 1, it looks like we went up 1. Do you agree? Over 1, up 1, 2, 3. Over 1, up 2, 4, 5. So it looks like it's a plus 1, plus 3, plus 5. It's strange because it's counting by 2s. You can see it probably better on the graph in front of you. The step pattern is 1, 3, 5, dot, dot, dot. We'll go over 1. I guarantee it'll be up 7. So from the halfway point here, over 1, up 1, 2, 3, 4, 5, 6, 7, plus 7. These will be the hardest problems you'll ever read for the step pattern, I promise. The direction of opening, is it up or down? It's opening up over here, for sure. The y-intercept, way over here. You're really good at this. It's 32, positive 32. The zeros, better known as the x-intercepts, we have one at positive 4 and one at positive 8. So we can go ahead and say, okay, one's at positive 4 and one's at positive 8. Whether the graph has a maximum or minimum, it's smiling. It's like Minnie Mouse, right? It's got a minimum, or you might just say it's the bottom of the parabola. Okay. And then lastly, the max or min value. What is the actual value here of the maximum minimum? So we go all the way over to our y-axis. Boom. You see it? Right at -4. Oh, interesting. Where else might we see -4? You see -4 anywhere else in this column here? Pardon me? It's the vertex's y value. Yeah, absolutely. So that vertex that's what I mean. It's so special. The vertex will tell us not only the axis of symmetry, right? This one over here, but it also tells us the optimal value. Now, we really got to think about whether this thing opens up or down to tell you whether it's a max or a min, but it does tell us that the optimal value is -4. And again, just planting a seed. Yeah? Okay, the next one here, we are going to fly. We got the blue one, and have a look at this equation. Negative. And we're like, oh yeah, it's got to be negative. That's why this thing is frowning. And -24, you can see it, -24, right over here, -20. So good, so good. Okay, according to the vertex, here we are. It looks like it's 4, 8. 4, 8. Okay, so I'm going to put a V beside it and say 4, 8. Lovely. Axis of symmetry. Again, look at the graph. Absolutely, yeah. Some of you are like, no, I don't need that graph. Once I got that vertex, I know that it's x equals 4. Okay. Now this step pattern. Now we got to be very careful. These are not nice parabolas. I guess they're nice parabolas, but they're not nice graphs. They're counted by 2's here, so we got to be very, very careful. Don't necessarily count the boxes, but count the value of those boxes. So when we go over 1, looks like we're going down 2. Down 2. So I'm going to write -2. Then we go over 1. Then we go down 2, 4, 6. Weird. Over 1. Down 2, 4, 6, 8, 10. Interesting, yeah. Yeah, for sure. So here's our step pattern. Of course, this is symmetrical. It should be the same thing on the other side. Over 1, down 2. Over 1, down 2, 4, 6. Over 1, down 2, 4, 6, 8, 10. Yeah. So step pattern. -2, -6, -10, dot, dot, dot. That's a little different. That's worth having a conversation about. Is this opening up or down? You're looking at me, you're like, it's opening down. Okay, y-intercept. You're like, I know, it's -24. Lovely. The zeros, you're so good at this. We got 6 and +2. Does it matter what order you put them in? No. You can put x equals 6, x equals 2, or x equals 2x. It doesn't matter. I like to do the lower one first. I don't know why. Max or min. This is a maximum. And without looking at the graph, what's the maximum value? +8? Hey, you're good. +8. Time out for just one moment. Why is the step pattern so strange? Why is this thing so nasty? What's going on here? Well, kind of. I see what you mean. I see what you mean. It's going over 1, down 2, over 1, down 6, over 1, down 10. Absolutely. But usually, wasn't it 1, 3, 5? Right? Remember that? Even this one. Look. 1, 3, 5, 7, 9, 11, 13, and it'll go, 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 go. What do you think? Yeah, it is. It is. And my question to that is, well, why? We know why it's negative, right? We know why it's negative. It's going downward. Of course, has to be. Now, before it was 1, 3, 5. Now it's 2, 6, 10. How does 2, 6, and 10 relate to 1, 3, and 5? What do you think, Tessa?
Because it's hitting every number.
Because it's hitting every number? Not sure what you mean by that.
Like 1, 2.
I know, it's strange. Do you have an idea?
Double.
It's double. Yeah, and Chris is like, yeah, it is double. And if you look carefully, check this out. The A value is 2. So this A value, well, this is probably worth even writing down. This A value, the A value, controls this step pattern. Now you're probably wondering, well, what do I mean by that? What do you mean that the A pattern, or sorry, the A value controls the step pattern? Well, let's have a look at this first one here. The first quadratic has an A value of what? What's the A value here? Well, yeah. A lot of us are thinking 0 because it's not there. But really, there's a hidden positive 1 right there. You agree? So in this quadratic over here, when we're thinking about the step pattern, we know that the step pattern is going to be 1, 3, 5. But like I said, A will control it. So what that means is it's going to be 1, 3, and 5, and dot, 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 but it's all going to be multiplied by whatever that A value is. And we said for this quadratic, this red one, that A value was 1, right? It was positive 1. So what happens is we'll say, okay, well, we're going to multiply the step pattern by positive 1. Really, it doesn't do anything to it. Multiplying by 1, we're like, sure, that was kind of a waste of time. But the reason why that's so important is because when we look at the step pattern over here, for this A value, and what's the A value for this blue quadratic? -2. Absolutely. When we talk about the step pattern here, 1, 3, 5, gotta consider the A value. Watch what happens. 1 times -2, 3 times -2, and 5 times -2. What happens next? Well, 1 times -2 is -2. 3 times -2 is -6. 5 times -2 is -10. Whoa, look at that. And that's where these numbers are coming from. I feel like I got way too excited about that. Everyone's like, okay, I can see it. It's doubled. All right, cool. Okay, I know. But that's it. That's all I got. Is there any questions about anything? I know, listen, you're sitting there and you're like, listen, this is information overload. It's probably because it is. I'm so thankful that we're getting to do this on a Friday. And also we got the rest of this period, or the rest of the morning, to chip away at this homework. It will go a lot faster than you might think, and you will become a lot more familiar with these types of terminology and properties and characteristics of these quadratics. We'll go on a break shortly. Is there any questions before I get Will his formula sheet? Questions? Absolutely.
I know a lot of
Yes, absolutely. Okay, I'm gonna turn this thing off here.